This is the first lecture for BBA students. The topic is frequency distribution part 1. We'll cover these points in this lecture: inclusive method and exclusive method, class limits, class boundaries, class mark or mid values, class width, open-end class, and relative frequency. All these topics we'll discuss in this lecture. So let us start with example number 1. The following are the scores in intelligence test conducted for 80 students in a certain class. So this is the data given for 80 students. These are the marks obtained by students. What we have to do, prepare a frequency distribution of the data taking suitable inclusive class interval. What does it mean by inclusive and exclusive? That we'll see in the next slide. For this purpose, first of all, we'll have to identify what is the maximum value and the minimum value. So maximum value is 137 and minimum value is 61. All these data should cover in class interval and it should be inclusive. So we are going to take the classes as a 60 to 69 so that the 61 will come, and last one we are taking 130 to 139 so that 137 will come. And this is inclusive type, so we will take as a 60 to 69, then there is a gap, and this is 70 to 79. Like this way we are going to take here. So these steps we will take a class interval. Once this class interval will take, then all these values one by one will come in some class interval. For example, 112, this 112 will come over here, and for that purpose we'll write a one vertical line that is called the telemark. Then 77 will come between this 70 to 79. So for this way we will make a vertical line. So for all these values, all this data, all these values will come in some class interval, and that will write as a heading as a telemark, and we'll write the vertical lines for this. Now you can see this is 1, 2, 3, 4. 4 entries are there, and the fifth entry we are writing like this way. So this becomes a set of 5. For example, here this is the set of 5 and this is 2. So total frequency it becomes the 7. Like this way, here the total frequency is, because 3 vertical lines, so 3 frequency, here 5 plus 2, so it is 7. Here 5 and 5, 10, 15 plus 1, that is 16. Like this way, after counting all this, we'll write here as a frequency. So by this way, this frequency distribution table is prepared. So it's very easy. First of all, decide class interval, then write telemarks, and counting this telemarks, we'll write frequency. How we are writing telemarks? We are identifying. As for example, again 103. 103 will come in this class interval. For that, we will write a vertical line. Now, what is mean by inclusive and exclusive method? Let us see. What is the inclusive method? In this method, the observation equal to upper limit is included in the same class. Therefore, the method is called inclusive method. In this case, the upper limit of the class is not the same as the lower limit of succeeding class. You can see in this example. Here it is in inclusive method 2002, 2000, 2099, and next there is a gap, and again new class is starting with 3002, 3999. So there is a gap. So such types of class intervals are called written in the inclusive method. Now here there is a discontinuity. Therefore, there is a discontinuity is observed between the classes. You can see there is a discontinuity. Next is starting with 3000 to 3999. Then is starting with 4000 to 499. Now in exclusive method, in this case, the observation equal to upper limit does not belongs to the same class. It means if there is an entry related to 3000, it will not come in this class, it will come in this class. So it is included in the next class, therefore the method is called exclusive method. Now in this case, the upper limit of one class is the lower limit of succeeding class. You can see here it is, the first class is 2000 to 3000, and next is starting again with the 3000 to 4000. So this method will call the exclusive method. So you can see again the difference between this. This is an example of inclusive method, and this is an example of exclusive method. This is the example of inclusive method. So keep this in mind. Now, what is meant by class limit and class boundaries? When there is a exclusive method, it means if it is say 10 to 20, 20 to 30, the next is 30 to 40, that is class interval is in exclusive form. In this case, class limits and class boundaries both are same. There is no difference. What is the class limit of this? The class limit is 10 to 20. What is the class boundary? Class boundary is again 10 to 20. Here the class limit is 20 to 30. What is class boundary? That is also 20 to 30, like this way. But if it is written in the inclusive form, then there is a difference. So let us see the definition. The two numbers designating the class intervals are called the class limit. You can see 10 to 19, this is the class limit. The class limit of this is 20 to 29. Class limit is 30 to 39. This is an inclusive method. Now, what is the class boundary? The class boundaries are the numbers up to which the actual magnitude of observation in the class can extend. The class boundaries are also called the actual limit or extended limit. As I told you, in case of inclusive only, there is a difference between class limit and class boundaries. So in case of inclusive, the class limits will be given like this way, and we'll have to find class boundaries. How to find this? We'll see what is the difference. The difference between the, if the classes are not continuous, then we need to determine class boundaries. If D is the gap between two classes, what is the gap between these two? You can see there is a gap of 190 and 19, and then starting with 20. So D is equal to 1 in this case. So how we will make the lower boundary? Lower boundary will become lower limit minus D by 2. So in this case, it will be 10 minus 1 by 2. That will understand with this example. Upper boundary कैसे बनेगी? तो upper boundary is upper limit plus D by 2. Okay. In case of exclusive method, as I told, class limit और class boundary जो आपकी रहेगी, that will be same. Now let us understand with an example. So convert the class limit into class boundaries. Now what is the need of converting this? Because it is in inclusive method. So this is an inclusive method. So this is the class limit. Now note that there is a gap between the first and second class interval, and the gap is of 1. So what is the lower boundary? What will be lower boundary? Lower boundary will be 10 minus D by 2. D is equal to 1. So 10 minus 1 by 2, that is 9.5. And the upper boundary will become 19 plus 1 by 2. 19 plus 1 by 2 means 0.5. So it will become 19.5. Like this way, this is for the first class. The same will be for the second class, and third will be for the third class. It will become 29.5 to 39.5. Like this way, we'll convert the class entry into class limit into class boundaries in case of inclusive method. Now, what is it mean by class mark or mid values and class width and open end class? We will see the next slide. So what is the class mark? Class mark or mid value, it is the midpoint of the class interval, and the same can be obtained as follows. कैसे find करेंगे? Mid value क्या होगी? Upper limit plus lower limit divided by 2, or upper boundary plus lower boundary divided by 2. So let us see the first class interval in case of class limit. If it is class limit given, then also there is a no problem. Just add the 10 plus 19 to 29 divided by 2, it is 14.5. If it is written in the case of class boundary, still there is a no problem, and same will come 9.5 plus 19.5 divided by 2. So it will be 29.5. 29 divided by 2, that is 14.5. So this mid value or class mark will be, we can obtain for all these classes. For first class it is 14.5. For the second class and third class also you can find the class mark or mid values. Now what does it mean by class width? Class width, it is actual length of the class interval. We can find class width by this formula. Class width, what will be? Upper boundary minus lower boundary. Now it is in exclusive method, that is 10 to 20, 20 to 30. It is written in exclusive form. So what will be class limit? Class width? Class width will be same as a 20 minus 10, that is 20 minus 10. So it will be 10. So class width is 10 for this. For the second also 30 minus 20, that will be 10. So in case of exclusive method, just upper limit, upper boundary or upper limit minus lower boundary. Now in case of inclusive, so you can see this is the example of inclusive. What we'll have to do? Lower limit of the succeeding class, lower limit of the succeeding class minus lower limit of the class under consideration. That is क्लास इंटरवल की बात कर रहे हैं तो लोअर लिमिट ऑफ सक्सीडिंग क्लास मतलब 20 माइनस लोअर लिमिट ऑफ द क्लास अंडर कंसिडरेशन, सो इट विल बी 10, 20 minus 10. ये 20 ये 10, 20 minus 10 is 10. सिमिलरली इस क्लास इंटरवल की बात कर रहे हैं तो 30 minus 20, so that is same like this way in case of class limits. And in case of class boundary there is no problem in case of class width. So in case of class boundary क्या होगा? आपकी class width is simply 19.5 minus 9.5. So this is for the first class. Class width in case of inclusive क्या होगा? So 20 minus 10, or you can take the upper boundaries also like this way, 29 minus 90. So either you find by 20 minus 10 like this way, or you find by 29 minus 19. So both answer will be same as a 10. So like this way class width you can find very easily. Now what is meant by open end class? Open end class means one of the boundary will not be there. These are not open end classes because 2000 to 3000 it is given, 3000 to 4000 it is given. But this is called open end class. Why? Because upper boundary is not specified. This will be the low open end class. Why? Because the lower boundary is not specified. So these types of classes are called the open end classes, in which one of the limit is not specified, is called open end classes. Okay. Now next topic is simply relative frequency. Now let us see what is mean by relative frequency. First of all, we'll understand by example and then we'll see what is the mean by relative frequency. So these are the marks, class intervals are given and these are the students are given. So marks is written over here. This is written as a frequency. And relative frequency, what we'll have to do, first of all, add all this frequency and we are getting the 100. So for the first class interval, the relative frequency will be 5 divided by total frequency 100, so it becomes 0.05. For the second class it is 25, this is written over here, divided by the total frequency, that is 100, so it will become 0.25. It means you will have to divide the frequencies with the total frequency, which is in this case 100, and you will get the relative frequency of each class. So that is very easy. Just if I want to find the relative frequency of this class, what we will have to do? It is written as a 27 as a frequency, total frequency which is 100. So 27 divided by 100 and we'll get as a 0.27. So that will become relative frequency of this class. Okay, so let me read this. What is written? Two different frequency distribution may not have the same total frequency. So this is just showing what is the use of relative frequency. Hence, for the purpose of comparison and interpretation, it is better to express the frequency of class in terms of proportion or percentage of the total number of observation. and this we obtained the proportion of number of observation in a class is relative frequency. How we'll obtain this? Class relative frequency is class frequency divided by total frequency. Okay, as I explained, this is 6. Suppose for this class interval I will have to find the relative frequency. So 6 divided by the total frequency is 100. So we'll get as a 0.06. So like this way relative frequency can be obtained. So thank you very much. This Beamer presentation, if you want, that can be downloaded from the link given in the description. So thank you.